In 1930, a 22-year-old farm boy with no college degree, working alone in a cold, dark room, stared at two photographs of the night sky and noticed something move. That tiny shifting dot became the most controversial world ever discovered. We named it after the god of the dead. We celebrated it for 76 years, and then, with a single vote, we erased it from the solar system and told ourselves it was nothing, a frozen pebble, a piece of forgotten debris drifting in the outer dark. We stopped looking, we stopped wondering, we moved on. That was the worst scientific mistake we almost made, because when we finally sent a spacecraft the size of a grand piano across 4 billion miles of freezing emptiness, what stared back at us from the void shattered every assumption we had ever held about this world. We expected a dead, cratered rock. Instead, we found a glacier the size of Texas, filled with churning toxic poison that devours everything it touches. Mountains made of frozen water harder than steel, floating across that poison like silent giants adrift at sea. A sky that bleeds red organic snow, and buried beneath miles of ice, an ocean of liquid water that has absolutely no right to exist. Pluto is not what we thought it was. It never was. And the deeper we look, the more it looks back. This is the true story of the most misunderstood world in the solar system. If you have ever believed that the most extraordinary things in the universe are hiding in plain sight, stay with us. And if stories like this one matter to you, consider subscribing and leaving a like. It genuinely helps us keep going deeper. We begin. Long before satellites and space telescopes, long before computers could scan the heavens in seconds, the search for new worlds was done by hand, by tired, aching, human hands. And the story of how Pluto was found begins not in some grand university or gleaming laboratory. It begins on a farm, a wheat farm in the flat, wind-beaten plains of Kansas, where a young man named Clyde Tombaugh spent his nights lying on his back in the dirt, staring up at the sky through a homemade telescope he had built from spare parts. He was not a professor. He had no degree. He was a 22-year-old farm boy who loved the stars more than anything else in the world, and that love would change the solar system forever. In the late 1920s, Clyde sent hand-drawn sketches of Jupiter and Mars to the Lowell Observatory in Flagstaff, Arizona. These were not casual doodles. They were detailed, careful, almost obsessive observations made through a telescope he had assembled from old car parts and pieces of farm machinery. The astronomers at Lowell were stunned. They saw in his drawings the precision and patience of someone born to watch the sky. So they offered him a job, not a glamorous one. Not at first. They hired him to do the most tedious, eye-destroying work in all of astronomy. They asked him to find a planet. Here is how the search worked. Every few nights, Clyde would attach a camera to a large telescope and photograph the same patch of sky. He would take 2 pictures of the same region, separated by a few days. Then he would place both photographs into a machine called a blink comparator. This device would rapidly switch back and forth between the 2 images. Stars, being unimaginably far away, would stay perfectly still between the 2 photos. But anything closer, anything inside our solar system, would shift its position slightly against that background of fixed stars. That tiny shift, that faint little jump, would be the giveaway. That would be the planet. Now, imagine doing this by hand. No computers, no software, no automation, just your eyes, a dim light, and 2 glass photographic plates covered with thousands of tiny dots. Every single dot had to be compared. Every flicker had to be investigated. Most of the time, the flicker turned out to be nothing. A speck of dust, a flaw in the glass, a trick of the eye after hours of staring. Night after night, week after week, month after month, Clyde Tombaugh sat in a small, dark room and blinked through the cosmos one frame at a time. He examined hundreds of thousands of stars. His eyes burned. His back ached. The work was brutal and lonely, and almost nobody believed he would find anything at all. But on February 18th, 1930, something moved. It was faint, incredibly faint, a tiny dot, barely visible, shifting just slightly between two plates taken on January 23rd and January 29th. Clyde leaned closer. He blinked the comparator again. The dot jumped. It jumped again. His heart began to pound. This was not dust. This was not a flaw. This was real. Something was out there, drifting slowly against the fixed stars, deep in the outer darkness of the solar system. He had found it. A new world. The first planet discovered by an American. The first new planet found in 84 years, since Neptune in 1846. And the man who found it was a farm boy with no college degree, sitting alone in a cold room in Arizona, squinting at glass plates in the dark. The discovery was announced on March 13th, 1930, a date chosen deliberately because it was the birthday of Percival Lowell, the wealthy astronomer who had founded the observatory and who had spent the final years of his life obsessed with finding a mysterious ninth planet. Lowell had died in 1916, 14 years before Pluto was found. He never saw his dream come true, but the observatory that bore his name carried his obsession forward, and Clyde Tombaugh finished the hunt. Now came the question that every new world demands. What do you call it? Suggestions poured in from around the globe. Some people wanted to name it after Percival Lowell himself. Others suggested mythological names like Minerva or Cronus. But the winning name came from the most unlikely of sources, a quiet 11-year-old girl in Oxford, England, named Venetia Burney. Over breakfast one morning, Venetia's grandfather read aloud from the newspaper about the new discovery. Without hesitation, the girl looked up and said one word: Pluto, the Roman god of the underworld, the ruler of the realm of the dead, a deity who lived in permanent darkness, far from the light of the living world. It was perfect. The name traveled from that breakfast table in Oxford to the Lowell Observatory in Arizona, and on May 1st, 1930, it was made official. The ninth planet of our solar system was named after the king of the dead, and here is a strange detail that most people never learn. The first two letters of Pluto, P and L, also happened to be the initials of Percival Lowell. Whether this was a coincidence or a quiet act of tribute, nobody knows for certain, but it fit. Everything about this discovery seemed to carry a kind of poetic gravity, as if the universe itself had been waiting for the right moment, the right person, and the right name. But even in those early days of celebration, there were whispers of doubt. The new planet was faint, far fainter than anyone had expected. If it was truly a planet, a real, a full-sized world like Neptune or Uranus, it should have been brighter. It should have been easier to find. Some astronomers began to wonder quietly whether this tiny dot was really what they thought it was. Was it truly a giant world hidden in the dark? Or was it something else entirely? Something much smaller, much stranger, and much harder to explain? That question would take decades to answer. And when the answer finally came, it would tear the solar system apart. There is one more thing worth knowing about Clyde Tombaugh. He never stopped looking up. After discovering Pluto, he continued scanning the sky for years. He catalogued hundreds of asteroids, thousands of variable stars, and 2 comets. He earned his degrees eventually, studied at the University of Kansas, and became a professor. But he never found another planet. Pluto was his one great gift to humanity. and when he died in 1997, a small container of his ashes was placed aboard a spacecraft. That spacecraft was called New Horizons. It launched in 2006, the same year Pluto was stripped of its title, and 9.5 years later, Clyde Tombaugh's remains flew past the world he had discovered, closer than any human-made object had ever been. The farm boy from Kansas finally visited his planet. But long before that bittersweet farewell, the story of Pluto's discovery was tangled with a much older, much stranger mystery. A mystery that began not with telescopes and photographs, but with mathematics and gravity and an invisible force that seemed to be pulling on the outer planets from somewhere no one could see. A phantom planet lurking in the equations, a ghost in the numbers. They called it Planet X. The story of Planet X begins long before Pluto. It begins with a problem, a mathematical problem that haunted astronomers for over a century. And to understand it, we need to go back to the discovery of Neptune, because that discovery planted a seed of obsession that would grow into one of the strangest wild goose chases in the history of science. In the early 1800s, astronomers noticed something odd about Uranus. The seventh planet was not behaving. It was not following its predicted orbit. Every time they calculated where Uranus should be, the planet drifted slightly off course, as if something invisible was tugging on it from the darkness beyond. Something massive, something hidden. Two mathematicians working independently, Urbain Le Verrier in France and John Couch Adams in England, they both sat down with pen and paper and tried to figure out where this invisible object had to be. They used nothing but gravity equations and pure logic. And in 1846, when telescopes were pointed at the exact spot Le Verrier had predicted, there it was, Neptune, a giant blue world hiding in the outer solar system, right where the math said it should be. This was one of the greatest triumphs in the history of science. A planet had been discovered not by looking through a telescope, but by solving an equation. Gravity itself had revealed the hidden world. And this success planted a dangerous idea in the minds of astronomers. If gravity wobbles led us to Neptune, then maybe, just maybe, there were more planets waiting to be found the same way. By the late 1800s, astronomers began to notice that even with Neptune accounted for, something still seemed slightly off about the orbits of the outer planets. The movements of Uranus and Neptune did not perfectly match the predictions. There were tiny leftover wobbles, small, unexplained nudges, as if yet another invisible hand was pulling on them from even deeper in the void. This is where Percival Lowell enters the story. Lowell was a wealthy Boston businessman with a passion for astronomy that bordered on obsession. He built his own observatory in Flagstaff, Arizona, high on a hill called Mars Hill, where the air was dry and the skies were dark, and he became consumed with the idea of finding this hidden world beyond Neptune. He called it Planet X. The X did not stand for the number 10, it stood for the unknown, a variable in an equation that had not yet been solved. Lowell spent years calculating where Planet X should be. He pored over orbital data, ran equations by hand, and published detailed predictions about its mass, its distance, and its position in the sky. He was absolutely convinced that a large, heavy planet was lurking in the outer darkness, pulling on Neptune and Uranus with its gravity. But Lowell had a problem. His math required Planet X to be big, very big, at least several times the mass of Earth. Otherwise, it would not have enough gravitational pull to cause the wobbles he was trying to explain. He searched and searched, but he never found it. He died in 1916 with his dream unfulfilled, buried on the grounds of his own observatory, staring forever at the sky he could never quite crack open. 14 years later, Clyde Tombaugh found Pluto almost exactly where Lowell had predicted Planet X should be. The celebration was enormous. The mystery was solved. Planet X had been found, except it had not. Not really. Because from the very beginning, something did not add up. The problem was simple but devastating. Pluto was too small. Way, way too small. Lowell's calculations demanded a planet at least 6 or 7 times the mass of Earth. When Pluto was first discovered, astronomers assumed it might be that big because they could not measure its size directly. It was just a faint dot of light, and a faint dot could be either a small bright object or a large dim one. For years, they gave Pluto the benefit of the doubt. They assumed it was large enough to be Planet X. But as telescopes improved over the following decades, the estimates of Pluto's size kept shrinking. First, it dropped to the mass of Earth, then half the mass of Earth, then 1/10, then 100th. By the time astronomers could measure it properly, the truth was unavoidable. Pluto is tiny. Its mass is roughly 1/500th of Earth's mass. It is smaller than our moon, far, far too small to cause any noticeable gravitational pull on giant planets like Uranus and Neptune. Pluto could not possibly be Planet X. It did not have the muscle. So how did Tombaugh find Pluto almost exactly where Lowell predicted a massive planet should be? This is the beautiful, strange, almost unsettling part of the story. It was a coincidence. One of the greatest coincidences in the history of science, so Lowell's math was wrong. His predictions were based on orbital wobbles that turned out to be measurement errors. The tiny discrepancies in the orbits of Uranus and Neptune that had launched the entire search were not real. They were caused by slightly incorrect estimates of Neptune's mass. When the Voyager 2 spacecraft flew past Neptune in 1989 and measured its mass precisely for the first time, the wobbles vanished. The orbits matched perfectly. There was no gravitational pull from a hidden planet. There never had been. Planet X was a ghost, a phantom born from bad data. And Pluto, the world that was found during the search for that phantom, was never the object anyone was looking for. It was a beautiful accident. A farm boy scanning the sky for a mathematical prediction that was wrong happened to stumble across a tiny, distant, frozen world that had nothing to do with the equations at all. The right discovery for the wrong reason. And here is where the story takes one more strange turn. Even though Lowell's Planet X was debunked, the idea of a large hidden planet in the outer solar system has never fully died. In 2016, 2 Caltech scientists named Konstantin Batygin and Mike Brown published a paper proposing that a genuine massive planet, perhaps 5 to 10 times the mass of Earth, may be orbiting the Sun at an enormous distance. They called it Planet 9. Their evidence was not based on wobbles in the orbits of Uranus or Neptune. Instead, they noticed that several small icy objects in the far outer solar system had strangely aligned orbits clustered together in a way that seemed too organized to be random. The best explanation, they argued, was the gravitational influence of a large unseen planet pulling them into formation. Planet 9 has never been observed directly. No telescope has captured its light. It remains, for now, a mathematical prediction, just like Planet X was a century before. Some astronomers believe it is real and simply too far away and too dim to detect with current technology. Others suspect the clustering of those distant orbits is just a statistical illusion, a pattern that our brains impose on randomness. The debate continues to this day, and the outer solar system keeps its secrets locked in the dark. But back in 1930, none of this mattered. Pluto had been found. It was named the ninth planet. It was printed in every textbook, taught in every classroom, memorized by every schoolchild on Earth. For 76 years, it sat comfortably at the end of the planetary lineup, small and distant and mysterious, but accepted, loved even. Generations of humans grew up with Pluto as part of their mental map of the cosmos. It was the underdog planet, the tiny one at the edge, the little world that belonged. And nobody imagined, not for a moment, that one day a room full of scientists would gather in a European city and vote to take it all away. For 76 years, Pluto lived among gods. Mercury, named after the messenger. Venus, the goddess of love. Mars, the god of war. Jupiter, the king of all gods. Saturn, Uranus, Neptune. And there, at the very end, sitting quietly in the cold, was Pluto, the god of the underworld, the ruler of the dead. 9 planets. That was the number. Every child on Earth learned it. Every textbook printed it. Every classroom poster displayed it. 9 circles orbiting a yellow sun, arranged in a neat, tidy line from hot to cold, big to small, light to dark. And Pluto was always the last one. The smallest circle, the farthest dot, the one you had to squint at on the poster because it was so tiny it barely registered. But it was there, and it mattered. There was something deeply personal about Pluto for people. It was the underdog, the runt, the little world at the edge that somehow earned its place alongside giants 1,000 times its size. Children drew it in crayon. Teachers pointed at it on chalkboards. Students invented little phrases to remember the order of the planets. My very excellent mother just served us 9 pizzas. Pluto was the pizza. It was the finish line. It completed the sentence. Without it, the solar system felt incomplete, like a song missing its final note. But even as the public fell in love with the 9th planet, scientists were quietly growing uncomfortable, because the more they learned about Pluto, the more it refused to behave like the other planets. And the cracks in its planetary identity started appearing almost immediately after its discovery. The first red flag was its orbit. Every other planet in the solar system orbits the Sun in a relatively flat, circular path, all of them staying close to an imaginary plane called the ecliptic. Their orbits are neat, orderly, and predictable. Pluto's orbit is nothing like this. It is stretched into a long, skinny oval shape, far more elongated than any planet's orbit should be, and it is tilted. While the other planets orbit on roughly the same flat disk, Pluto's path is tilted 17 degrees off that plane, cutting through the solar system at a steep angle like a car driving across a highway instead of along it. Even stranger, Pluto's orbit actually crosses Neptune's orbit. For about 20 years out of every 248-year trip around the Sun, Pluto is actually closer to the Sun than Neptune is. This happened most recently between 1979 and 1999. During those 2 decades, Neptune was technically the farthest planet from the Sun, and Pluto was closer. No other planet behaves like this. No other planet crosses another planet's lane. It was as if Pluto had never read the rules. The second red flag was its size. As telescopes improved through the 20th century, astronomers kept revising their estimates of Pluto's size downward. In the 1930s, some thought it might be as massive as Earth. By the 1950s, that estimate had dropped dramatically. By the 1970s, it was clear that Pluto was smaller than our Moon. Not by a little, by a lot. Pluto's diameter is only about 1,400 miles. Our Moon is over 2,000 miles across. The planet that generations had memorized and celebrated was smaller than the rock that orbits our own world every single night. The third red flag was its composition. The rocky inner planets, Mercury, Venus, Earth, and Mars, are made of rock and metal. The gas giants, Jupiter and Saturn, are made of hydrogen and helium. The ice giants, Uranus and Neptune, are made of heavy icy compounds. Pluto fit none of these categories. It was a strange mixture of rock and frozen gases, nitrogen ice, methane ice, carbon monoxide ice. It did not belong to any of the established planetary families. It was an orphan sitting at a table full of strangers. And then came the discovery that truly began to unravel everything. In 1978, astronomer James Christie was studying photographs of Pluto when he noticed something peculiar. The image of Pluto appeared slightly elongated, as if something was bulging out from one side. At first, he thought it was a photographic defect, but when he checked older images, the bulge appeared again and again, always in a different position. It was not a flaw, it was a moon. Pluto had a companion. They named it Charon, after the ferryman who carried souls across the river of the dead in Greek mythology. But Charon was not just any moon. It was enormous compared to Pluto. Charon's diameter is roughly half of Pluto's diameter. No planet in our solar system has a moon that is even close to half its own size. Earth's moon is about a quarter of Earth's diameter, and that is already considered unusually large. Charon was so massive relative to Pluto that the two did not orbit in the normal way. Instead of Charon orbiting a point inside Pluto, they both orbited a point in empty space between them, a shared center of gravity hanging in the void. This made them look less like a planet and its moon, and more like two objects dancing together as equals, a binary system spinning in the dark. By the 1990s, the uncomfortable questions were piling up. Pluto was tiny. Its orbit was strange. Its composition was odd. Its moon was almost as big as it was. And then astronomers started finding other objects out beyond Neptune that looked suspiciously similar. In 1992, a small icy body was discovered orbiting beyond Neptune. Then another. Then another. Then dozens more. These objects were given a collective name. They were called the Kuiper Belt, a vast ring of frozen debris left over from the formation of the solar system, stretching far beyond Neptune into the cold outer dark. And Pluto, it turned out, was sitting right in the middle of it. Suddenly, Pluto did not look like a lonely planet, bravely holding its position at the edge of the solar system. It looked like the biggest member of a vast swarm. One object among thousands. A king of rubble, perhaps, but not a planet. Not in the way Mercury or Jupiter or Earth are planets. The question that had been whispered for decades was now being spoken out loud. Is Pluto really a planet at all? Or is it something else? Something smaller? Something humbler? Something that belongs to a completely different category? The final blow came in 2005, when astronomer Mike Brown and his team discovered a distant icy object that appeared to be even larger than Pluto. They called it Eris, after the Greek goddess of discord, and the name could not have been more appropriate, because Eris threw the entire solar system into chaos. If Pluto was a planet, then Eris had to be a planet too. And if Eris was a planet, then what about all the other large icy objects being found in the Kuiper Belt? Were they all planets? Were there suddenly 12 planets? 20? 50? The solar system needed a definition, a clear, hard, scientific line that separated planets from everything else. And drawing that line would require a vote that would break millions of hearts, a vote that would strip the underdog of its crown and send it into exile. The gods of the solar system were about to hold a trial, and Pluto, the smallest among them, the quietest, the most distant, the most loved, was about to be judged. The verdict would come on a warm summer afternoon in Prague, in a room full of astronomers who were about to do something that no scientific body had ever done before. They were about to kill a planet. August 24th, 2006, Prague, Czech Republic. A grand hall filled with astronomers from around the world. The International Astronomical Union, the organization responsible for naming and classifying everything in the sky, had gathered for its general assembly. Thousands of scientists had traveled to this beautiful European city to discuss telescopes and galaxies, the usual business of astronomy. But everyone knew the real reason they were there. Everyone knew what was coming. The fate of Pluto was on the table, and by the end of the day, the solar system would never be the same. The problem that had brought them to this moment was simple but painful. Astronomy had never formally defined the word planet. For thousands of years, the meaning had seemed obvious. Planets were the big, bright wanderers that moved across the night sky. The ancient Greeks had named them. Galileo had studied them. Generations of scientists had explored them. Everyone knew what a planet was, until they did not. The discovery of Eris in 2005 had forced the issue. Here was an object beyond Neptune that appeared to be roughly the same size as Pluto, maybe even bigger. If Pluto was a planet, then Eris was a planet. And if Eris was a planet, then several other large Kuiper belt objects probably qualified too. The solar system was threatening to balloon from 9 planets to 12 or 15, or eventually dozens. Textbooks would need constant rewriting. The neat and orderly model of the solar system that every child learned in school would dissolve into a chaotic mess of icy dwarfs and frozen debris, all claiming the title of planet. Something had to give. The IAU proposed a definition, 3 rules, 3 simple tests that a celestial body had to pass to be called a planet. First, it must orbit the sun. Second, it must have enough mass for its own gravity to pull it into a roughly round shape. Third, and this was the killer, it must have cleared the neighborhood around its orbit. That third rule was the guillotine. Clearing the neighborhood means that over time, a true planet must become the dominant gravitational force in its orbital zone. It must either absorb, deflect, or eject all the smaller debris sharing its path. Earth has done this. Jupiter has done this. Every major planet has swept its orbit clean over billions of years. Pluto has not. Pluto orbits in the Kuiper belt, surrounded by thousands of similar icy objects. It shares its space with a swarm. It has not cleared its neighborhood. It has not dominated its zone. The vote took place on the final day of the assembly, and here is the detail that still makes many people angry. Of the roughly 10,000 members of the IAU, only about 424 were in the room when the vote happened. Most members had already gone home. The decision that would reshape the solar system, the decision that would strip a beloved world of its title, was made by less than 5% of the organization. 4% of the club decided the fate of a world that billions of people loved, and the result was decisive among those who voted. Pluto failed the third test. It had not cleared its orbit. Therefore, under the new definition, it was not a planet. The IAU created a new category for it. They called it a dwarf planet. Not a planet, not an asteroid, not a comet. A dwarf planet. A new label for a world that did not quite fit anywhere else. The reaction was immediate and explosive. The public was furious. People who had grown up with 9 planets felt like something had been stolen from them. Pluto was not just a dot on a chart. It was a childhood memory. It was the final word in the sentence. It was the pizza letters poured in from schoolchildren begging the IAU to change its mind. Protests appeared outside planetariums. Bumper stickers showed up on cars reading, "Honk if Pluto is still a planet." The state of New Mexico, where Clyde Tombaugh had lived and worked, passed a resolution declaring that Pluto would always be considered a planet within its borders. Illinois did the same. It was as if a small, harmless creature had been kicked out of the family, and the whole world rose up to defend it. But the anger was not just emotional. Many respected scientists were also deeply unhappy with the decision. Alan Stern, the principal investigator of the New Horizons mission, the man who had spent years of his life building a spacecraft to visit Pluto, was one of the most vocal critics. He argued that the definition was fundamentally flawed. The idea of clearing your orbit, he said, was ridiculous when applied to the outer solar system. The farther a planet is from the Sun, the larger its orbital zone becomes. Pluto's orbit is enormous, billions of miles in circumference. Expecting any object to gravitationally clear such a vast region is unreasonable. Even Earth, if placed in Pluto's orbit, would fail the test. By the IAU's definition, Earth itself would not be a planet if it orbited where Pluto does. The definition punishes distance, Stern argued, not character. Other scientists pointed out that the definition excludes exoplanets entirely. The thousands of planets discovered around other stars cannot be tested for whether they have cleared their orbits because we simply cannot observe their orbital zones in enough detail. The definition only works inside our own solar system, which makes it parochial and limited. A good scientific definition, critics argued, should be universal. The debate continues to this day. It has never been fully resolved. There are still planetary scientists who refuse to use the term dwarf planet. There are still textbooks that include Pluto in the planetary lineup with an asterisk. There are still conferences where the argument erupts with surprising heat and passion. The question of what counts as a planet remains one of the most emotionally charged debates in all of science, not because the physics is complicated, but because the word planet carries weight. It carries meaning. It carries identity. And there is a strange irony buried in all of this. The very year that Pluto was demoted, the very same year the IAU declared it was not worthy of the title planet, a small spacecraft was already hurtling through space toward it. New Horizons had launched on January 19th, 2006, 7 months before the vote. It was already on its way, already crossing the void, already carrying the ashes of Clyde Tombaugh toward the world he had discovered 76 years earlier. The spacecraft did not care about definitions. It did not care about votes. It had a job to do. It was going to visit Pluto, and it was going to show us what this little world truly looked like, no matter what we chose to call it. The journey would take 9.5 years, nearly a decade of silence, of coasting through the emptiness between worlds, of falling deeper and deeper into the cold outer dark. And when New Horizons finally arrived, when its cameras finally opened their eyes and looked at Pluto for the first time, what they saw would silence every argument. Because Pluto did not look like a piece of debris. It did not look like a minor member of a swarm. It looked like a world. A complex, active, breathtaking, terrifying world. And it had a heart. But the crossing came first. And the crossing was its own kind of nightmare. On January 19th, 2006, a small spacecraft no bigger than a grand piano sat on top of a massive rocket at Cape Canaveral, Florida. It weighed about 1,000 pounds. It carried 7 scientific instruments, a small nuclear battery, and a tiny container holding some of the ashes of Clyde Tombaugh. In a few hours, it would become the fastest object ever launched from Earth. The mission was called New Horizons, and its destination was a world that most of humanity had already begun to forget. The launch was violent and beautiful. The Atlas V rocket roared to life and punched through the atmosphere with such force that New Horizons reached escape velocity faster than any spacecraft before it. Within 9 hours of launch, it had already crossed the orbit of the Moon. A journey that took the Apollo astronauts 3 days, a New Horizons accomplished before dinner. It was moving at roughly 36,000 miles per hour relative to Earth, and it was still accelerating. By the time it settled into its cruise speed, it was traveling at approximately 50,000 miles per hour. A bullet fired from a rifle travels at about 1,700 miles per hour. New Horizons was moving almost 30 times faster than a bullet, and it still was not fast enough. Even at that blistering speed, the journey to Pluto would take 9.5 years. That number is difficult to truly absorb. Think about everything that has happened in your life over the past 9.5 years. Every meal you have eaten, every conversation you have had, every night you have slept, every season that has changed. Now imagine that during all of that time, a tiny machine the size of a piano was silently flying through the emptiness of space, getting a little bit closer to Pluto every single second, and still not there yet. The route was not a straight line. In February 2007, about 13 months after launch, New Horizons swung past Jupiter for a gravity assist. It used the giant planet's enormous gravitational pull like a slingshot, stealing a bit of Jupiter's orbital energy to boost its own speed by about 9,000 miles per hour. As it flew past, it snapped photographs of Jupiter's clouds, its moons, and its faint ring system. It was a brief, productive visit, like a traveler stopping at a gas station on a very long highway. And then it kept going, deeper, farther, into the emptiness. After Jupiter, there was nothing. Nothing for 8.5 more years. I'd no planets to photograph, no moons to study, no gravity assists to catch. Just the black vacuum of interplanetary space stretching in every direction. The spacecraft entered a state called hibernation. Most of its systems were shut down to conserve energy and reduce wear on its electronics. A single beacon signal was sent back to Earth once a week, just a simple beep to let mission control know it was still alive. That beep took hours to reach Earth, traveling at the speed of light across the growing chasm between the spacecraft and home. Imagine the loneliness of that crossing. Not the human loneliness, because New Horizons has no feelings, no consciousness, but a physical loneliness, a spatial loneliness. With every passing day, the spacecraft moved farther from the sun, and the sun grew smaller behind it. At Earth, the sun fills the sky with blinding light and warmth. At Jupiter, it is noticeably smaller, but still clearly the sun. At Saturn's distance, it shrinks further. By the time you reach the orbit of Pluto, nearly 4 billion miles from home, the sun is no longer a disk, it is a point. A very bright star, yes. Brighter than anything else in the sky, but just a point. A dot of light in an ocean of black. The warmth is gone. The light is hundreds of times dimmer than a cloudy afternoon on Earth. If you were standing on Pluto's surface at noon, the sky would not be blue. It would be black, a permanent twilight that never lifts. Noon on Pluto looks like deep night on Earth. The temperature out there is almost incomprehensible. Space near Pluto hovers around -380 to -390 degrees Fahrenheit. At these temperatures, gases that we breathe and take for granted on Earth, nitrogen, oxygen, become solid. They freeze into rock-hard ice. The air you are breathing right now would be a frozen crystal on Pluto's surface. This is not merely cold. This is a kind of cold that has no comparison in human experience. It is the cold of absence, the cold of a place that the sun has almost forgotten. And through this frozen dark, New Horizons flew alone for years. The mission team back on Earth had to live with a terrifying reality during this crossing. If anything went wrong, if a micrometeorite struck the spacecraft, if a computer glitched, if a thruster failed, there was no way to fix it. No rescue mission could be sent. No backup spacecraft existed. New Horizons was the only machine humanity had ever pointed at Pluto, and it was carrying decades of scientific ambition on its tiny frame. One speck of dust traveling at high speed could end everything. There is also a strange time delay that made the mission even more nerve-wracking. At Pluto's distance, a radio signal traveling at the speed of light takes about 4.5 hours to reach Earth. That means when New Horizons sent a message saying everything is fine, the message described a reality that was already 4.5 hours old by the time anyone heard it. And if Mission Control wanted to send a command back, that command would take another 4.5 hours to arrive. A 9-hour round trip for a single conversation. During the closest approach to Pluto, the spacecraft was entirely on its own. It had to execute its observations automatically, following a pre-programmed sequence of commands uploaded days in advance. If anything went wrong during the flyby, nobody on Earth would even know about it until hours later. On July 14th, 2015, after 9.5 years of silence and darkness, New Horizons reached Pluto. It screamed past at over 30,000 miles per hour, passing within 7,800 miles of the surface. For a few frantic hours, every instrument on board was working at maximum capacity, photographing, scanning, measuring, tasting the thin atmosphere, mapping the surface in detail never before imagined. It captured everything it could in one breathless pass, because there would be no second chance. There was no fuel to slow down, no way to enter orbit. It was a flyby. One shot, one look, one chance to see what 4 billion miles of darkness had been hiding. And then the data began its long journey home. Traveling at the speed of light, each packet of information took 4.5 hours to reach Earth. And because the signal was so faint and the transmitter so small, the total download of all the data collected during the flyby took over 15 months. More than a year of patient listening, pulling images and measurements out of the static one tiny piece at a time. But the very first image that arrived changed everything. It appeared on screens at Mission Control, and the room went silent. There, on the face of this frozen exile, this tiny world that we had stripped of its title and dismissed as debris, was a shape that no one had expected. A giant, perfectly formed heart. Bright, pale, enormous, stretching across the equator like a message carved into the surface of a world that had been waiting in the dark for 85 years for someone to finally come and look. Scientists stared at it. The public stared at it. The whole world stared at it. And for one brief, beautiful moment, Pluto stared back. But that heart was not what it seemed. Beneath its pale beauty lay something far stranger and far more terrifying than anyone had imagined. When the first high-resolution image of Pluto arrived on Earth, the world fell in love. Social media exploded. News channels ran the image on loop. People shared it with heart emojis and called it the cutest thing in the solar system. A frozen world 4 billion miles away had just sent us a Valentine. A giant, perfectly shaped heart glowing pale and bright against the darker surface around it. It was romantic. It was poetic. It was beautiful. and it was one of the most dangerous landscapes ever discovered in the solar system. The heart spans roughly 1,000 miles across. To put that in perspective, if you placed it on the surface of the United States, it would stretch from New York to Denver. It dominates the left side of Pluto's visible face, impossible to miss, perfectly symmetrical, almost suspiciously perfect. Scientists named the left lobe of the heart Sputnik Planitia, after the first artificial satellite ever launched into space. And when they began analyzing the data from New Horizons, what they found inside that heart made them go very quiet. Sputnik Planitia is not a gentle frozen meadow. It is a colossal impact basin, a crater formed when something enormous slammed into Pluto's surface billions of years ago. The collision was so violent that it carved out a depression hundreds of miles wide and several miles deep. And over time, this vast bowl filled up. Not with water, not with dust. It filled with frozen nitrogen, frozen methane, and frozen carbon monoxide. A cocktail of toxic ices pooling in the lowest point on Pluto's surface, like poison collecting in a wound. What sits inside Sputnik Planitia today is essentially a glacier the size of Texas. But this is not a glacier like anything on Earth. On our planet, glaciers are made of water ice. They are cold, hard, and they move extremely slowly, sometimes just a few inches per year. The glacier inside Pluto's heart is made of nitrogen ice, and nitrogen ice behaves very differently from water ice. It is softer, more pliable, more willing to flow, and most importantly, it responds to heat in ways that make the entire basin come alive. Deep beneath Pluto's surface, the planet's core still holds a small reserve of radioactive elements. These elements decay slowly over billions of years, releasing a faint but persistent trickle of heat. This heat rises upward through the frozen layers like warmth from a buried ember. When it reaches the base of the nitrogen glacier in Sputnik Planitia, something remarkable happens. The nitrogen at the bottom of the glacier warms up slightly. Not enough to melt it, but enough to make it less dense than the nitrogen above it. The warmer nitrogen begins to rise, the cooler nitrogen above begins to sink, and a slow, churning cycle is born. Scientists call this process convection. It is the same process that drives the bubbling of boiling water in a pot on your stove. The only difference is scale and temperature. Instead of water in a pot, you have a 1,000-mile-wide basin of frozen poison. Instead of a flame beneath the pot, you have the faint radioactive whisper of a dying core. And instead of bubbles breaking the surface in seconds, each convection cycle in Sputnik Planitia takes roughly 500,000 to 1 million years to complete. A single bubble of churning nitrogen takes longer to rise and fall than the entire span of human civilization. But the evidence of this churning is written clearly on the surface. When New Horizons photographed Sputnik Planitia in high resolution, scientists saw an unmistakable pattern. The glacier is divided into large polygonal cells, irregular shapes roughly 20 to 30 miles across, separated by shallow troughs. These cells are the tops of convection columns, warm nitrogen rising in the center of each cell, spreading outward across the surface, cooling, and then sinking back down at the edges. The entire glacier is slowly boiling, turning over, renewing itself in an endless cycle of frozen motion. And this churning has a terrifying consequence. The surface of Sputnik Planitia is almost perfectly smooth. Across the entire 1,000-mile expanse, there are virtually no impact craters. Zero. In a solar system where every solid surface is pockmarked with craters from billions of years of asteroid bombardment, this blank smoothness is deeply unusual. It means the surface is young. Geologically speaking, it is practically newborn. Scientists estimate that the surface of Sputnik Planitia is no more than 10 million years old. On a world that is 4.5 billion years old, 10 million years is yesterday. The reason for this youthfulness is the convection itself. When an asteroid or a chunk of space rock crashes into the surface of the glacier, it does leave a crater, but the crater does not last. The slow, churning motion of the nitrogen ice gradually pulls the crater apart. The walls soften, the edges blur. The debris is swallowed downward into the convective flow. Within a few 100,000 years, the crater is gone, completely erased, absorbed into the freezing depths as if it never existed. The glacier eats its own scars. Think about that for a moment. This is a surface that devours anything that touches it. Any rock that falls from space, any fragment of debris that dares to mark this frozen sea is slowly and silently consumed. Dragged beneath the surface, dissolved into the churning belly of a toxic glacier. It is a pristine white expanse that heals itself by swallowing everything. And the heart does something else that scientists did not expect. It drives Pluto's weather. The nitrogen ice in Sputnik Planitia is constantly sublimating, turning directly from solid ice into gas under the faint warmth of the distant sun. This nitrogen gas rises into Pluto's thin atmosphere and drifts across the planet. When it reaches the colder regions on the other side, it freezes again and falls back to the surface as nitrogen frost. Eventually, this frost makes its way back to Sputnik Planitia through glacial flow, and the cycle repeats. Pluto has a nitrogen cycle, eerily similar to Earth's water cycle. Evaporation, atmospheric transport, precipitation, and return flow. A weather system powered by a toxic heart. There is one more detail about Sputnik Planitia that adds to its strangeness. The basin is located almost exactly opposite to Charon on Pluto's surface. This is not a coincidence. The massive weight of all that nitrogen ice, miles deep, pooled in one spot, creates a gravitational anomaly. Scientists believe that this extra mass actually helped reorient Pluto over millions of years, causing the entire world to slowly tip until the heavy heart settled into its current position, locked in alignment with the tidal forces from Charon. The heart moved the planet. The wound became so heavy with poison that it dragged the entire world around to face a new direction. The media called it cute. They put heart emojis next to it. They made it into t-shirts and phone wallpapers and Valentine's Day cards. But Sputnik Planitia is not cute. It is a 1,000-mile wide wound filled with churning toxic ice that eats everything it touches, drives the weather of an alien world, and once rotated the entire planet to suit its gravitational appetite. And at the edges of this monstrous heart, where the white glacier meets the darker terrain, the landscape becomes even more alien. Because that is where the mountains begin. Mountains unlike anything found anywhere else in the known solar system stand at the edge of Sputnik Planitia and look outward. Behind you stretches the vast white plain of the nitrogen glacier, smooth and pale, slowly churning in its million-year cycles. But ahead of you, the landscape erupts. The flat terrain breaks apart and rises violently upward into jagged peaks that claw at a sky of permanent black. These are the mountains of Pluto, and they are made of something that would stop you cold if you understood what you were looking at. On Earth, mountains are built from rock, granite, basalt, limestone. Tectonic plates collide over millions of years, forcing slabs of stone upward into the sky. The Himalayas, the Andes, the Rockies, they are all monuments of crushed and folded rock. On Pluto, rock exists deep inside the core, but on the surface, it plays almost no role at all. The surface temperature on Pluto drops to around minus 390 degrees Fahrenheit. At this unimaginable cold, something strange happens to water. something that changes the rules of what a mountain can be. At room temperature, water is a liquid. You drink it, you swim in it, you pour it from a glass, cool it down to 32 degrees Fahrenheit, and it becomes ice. Ordinary ice, the kind that cracks under your boot and melts in your hand. But keep cooling it. Drop the temperature further and further, past anything you have ever experienced on Earth, past the coldest Antarctic night, past the freezing point of carbon dioxide, past the freezing point of nitrogen and oxygen, all the way down to minus 390 degrees. At that extreme, water ice undergoes a transformation. It does not just get colder. It becomes a completely different material. It becomes as hard as granite, as rigid as steel, as strong as bedrock. The mountains of Pluto are made of water ice, pure, solid, frozen water. But at Pluto's temperatures, that water ice is no longer the fragile, slippery substance you know from Earth. It is structural stone. It can hold enormous weight. It can fracture into sharp, jagged edges. It can tower thousands of feet into the air without crumbling. Water, the same molecule that flows gently through rivers on our world, becomes the building material of alien mountain ranges in the deep outer dark. New Horizons revealed 2 major mountain ranges near the edges of Sputnik Planitia. Scientists named them Norgay Montes, after Tenzing Norgay, one of the first 2 men to summit Mount Everest, and Hillary Montes, after Sir Edmund Hillary, the other. These names were not chosen casually. They were meant to honor the spirit of exploration and the conquest of impossible peaks. And the peaks they were given to are truly impossible by any earthly standard. Norgay Montes contains individual mountains rising over 11,000 feet above the surrounding terrain. Imagine standing at the base and looking up. A wall of frozen water, jagged and sharp like broken glass, soaring more than 2 miles into a pitch-black sky with no atmosphere to scatter light. No blue haze to soften the edges. Just raw, crystalline ice against infinite darkness. The peaks catch the faint light of the distant sun and glitter faintly, cold and alien and beautiful in a way that no human eye has ever directly witnessed. Hillary Montes is slightly lower, but no less dramatic. Its peaks rise to roughly 5,000 feet, forming a chaotic jumble of icy ridges and fractured blocks. Together, these 2 mountain ranges frame the western edge of Sputnik Planitia, like the walls of a colossal frozen arena. But here is where things become truly strange. These mountains do not stay in one place. Remember what Sputnik Planitia is made of: nitrogen ice. And remember what the mountains are made of: water ice. Now here is a simple but profound fact of physics. Water ice is less dense than nitrogen ice. On Earth, we see this principle every day. Oil floats on water because oil is less dense. Ice cubes float in your drink because solid water is less dense than liquid water. On Pluto, the same principle applies, now but with different materials. Water ice is the lighter substance. Nitrogen ice is the heavier one. So, when chunks of water ice break off from the mountain ranges at the edge of the glacier, they do not sink. They float. They float on the nitrogen glacier like icebergs on an Arctic ocean. New Horizons captured images of these floating mountains drifting across the surface of Sputnik Planitia. Massive blocks of water ice, some of them miles across, sitting on top of the nitrogen plain and slowly moving with the convective currents beneath them. The churning motion of the glacier carries these ice mountains across the basin at speeds that are imperceptible in human time, but dramatic over thousands and millions of years. They drift, they collide, they cluster together in groups. Some of them pile up against the edges of the convection cells, forming chains of icy debris along the troughs between the polygonal patterns. Picture this scene in your mind. a flat white plain stretching to the horizon under a black sky. The surface is smooth but alive, slowly breathing with the convective motion below. And scattered across this plain, like ships frozen in a dead calm sea, are mountains, entire mountains, floating, drifting slowly in silence across a glacier of frozen poison. No sound, no wind, no waves, just enormous masses of crystalline water ice gliding through the dark on a current of churning nitrogen. One particular cluster caught the attention of scientists. They informally called it the Challenger Coals, after the Space Shuttle Challenger crew. This cluster of floating ice blocks sits near the center of Sputnik Planitia, gathered together like a group of refugees huddled in the middle of a frozen sea. Scientists believe these blocks were carried to their current position by the convective flow and deposited where the currents converged, like driftwood collecting in the center of a slow whirlpool. There is something deeply unsettling about this image. We think of mountains as permanent, as anchored, as the most solid, immovable things on a planet's surface. On Earth, mountains are symbols of stability. They do not move, they do not drift. They define the landscape for millions of years. On Pluto, mountains are vagabonds. They wander. They break free from the edges of the world and float across a sea of toxic ice with no destination and no anchor. They are homeless giants drifting through a frozen wasteland. And if you were somehow standing on the shore of Sputnik Planitia, watching one of these mountain ranges drift slowly toward you across the white plain, you would notice something else. Something on the peaks, something on the slopes and ridges that would make you stop and stare. A color that has no business being on a world this cold and this dead. The peaks of these mountains are not white. They are stained, coated in a fine layer of something dark, something the color of dried blood. A reddish-brown dust that clings to every high surface, every exposed ridge, every frozen summit. It is not soil, it is not rust. It is something far stranger and far more ancient. Something that falls from the sky like a slow, eternal, crimson rain. And understanding where that red stain comes from will take us into one of the most bizarre chemical processes in the entire solar system. A process that turns simple sunlight and frozen gas into something that might just be the beginning of life itself. Look closely at the mountains of Pluto. Look at the ridges, the peaks, the high frozen plains that rise above the nitrogen glacier. They are not clean. They are not the pure, brilliant white you might expect from a world made of ice. Instead, they are stained. A dark, reddish-brown coating covers the highlands like dried paint on ancient stone. From a distance, it looks like rust, like old blood, like a world that has been slowly bleeding for millions of years. And in a way, it has. This red stain has a name. Scientists call it tholins. The word was invented in 1979 by the astronomer Carl Sagan, borrowed from the ancient Greek word tholos, meaning muddy or unclear. And tholins are indeed unclear. They are not a single substance. They are a messy, complex family of organic molecules with chains of carbon, hydrogen, nitrogen, and oxygen tangled together in ways that are still not fully understood. They are not alive. They are not biological. But they are organic in the chemical sense, meaning they are built from the same basic elements that life is built from. And the way they form on Pluto is one of the strangest chemical recipes in the solar system. It starts with sunlight. Even 4 billion miles from the sun, a small amount of ultraviolet radiation still reaches Pluto's surface. It is faint, hundreds of times weaker than the sunlight that reaches Earth, but it is there. And when this ultraviolet light strikes the frozen methane that coats parts of Pluto's surface, it triggers a reaction. The UV energy breaks apart the methane molecules, snapping the bonds between carbon and hydrogen atoms. These freed atoms do not just sit still, they recombine. They grab onto each other in new configurations. Carbon links to carbon. Nitrogen joins the chain. Hydrogen fills in the gaps. Layer by layer, bond by bond, simple molecules are transformed into larger, heavier, more complex compounds. These new compounds are tholins, and they are red. The process is slow, unimaginably slow. Each individual molecule forms over timescales that dwarf a human lifetime. But Pluto has had billions of years. 4.5 billion years of faint sunlight hitting frozen methane, triggering reaction after reaction after reaction, building up a reservoir of reddish organic sludge one molecule at a time. Over those eons, the tholins have accumulated. They coat the surface, they settle into cracks, they dust the mountain peaks, they paint the highlands in shades of crimson and rust and dark amber. And they do not just form on the ground. Tholins also form in Pluto's atmosphere. Pluto has an extremely thin atmosphere, mostly nitrogen with traces of methane and carbon monoxide. When ultraviolet light hits the methane molecules floating high in this thin atmospheric layer, the same chemical reaction occurs. Tholins form in the sky itself, tiny particles of reddish organic haze suspended miles above the surface. And then, slowly, they fall. They drift downward through the thin air like the finest, slowest snowfall you could ever imagine. A dark red rain that never stops. This is not rain as you know it. There are no drops, no puddles, no sound of falling water. It is more like a permanent dusting, a constant, invisible descent of microscopic organic particles settling onto every surface they can reach. The mountains catch it on their peaks, the ridges collect it in their crevices, the high plains absorb it into their icy surfaces. Over millions of years, this gentle red rain has coated Pluto's highlands in a layer of dark organic dust, transforming a world of bright white ice into something that looks ancient and wounded and strangely alive. The tholins are not evenly distributed across Pluto's surface. They tend to accumulate on higher terrain, on the mountain peaks and the elevated regions surrounding Sputnik Planitia. The reason is connected to the nitrogen cycle we explored earlier. The low-lying areas, especially the basin of Sputnik Planitia itself, are constantly being resurfaced by fresh nitrogen ice. The convective churning of the glacier, the sublimation and redeposition of nitrogen frost, these processes keep the low areas clean and white. The tholins that fall there get buried or swept away. But on the high ground, where nitrogen ice is thinner or absent, the tholins have nowhere to go. They just accumulate. Layer upon layer, century after century, painting the peaks in ever darker shades of red. The result is a world with a haunting color palette. Bright white plains of nitrogen ice. Dark reddish-brown highlands stained with organic dust. Patches of grey and amber where different ice compositions meet. And all of it under a sky of pure black, lit by a sun so distant it looks like nothing more than an unusually bright star. It is beautiful in a way that is hard to describe. Not the warm beauty of a sunset or a forest, a cold beauty, an alien beauty, the beauty of something that was never meant to be seen by human eyes. Now here is the part that keeps certain scientists awake at night. Tholins are organic molecules. They are made of carbon, hydrogen, nitrogen, and oxygen. These are the exact same elements that form amino acids, the building blocks of proteins, the foundations of life as we know it. Tholins themselves are not alive. They are not DNA. They are not proteins. But they are a step in that direction. They represent what some scientists call prebiotic chemistry, the kind of complex organic chemistry that might eventually might under the right conditions lead to the formation of the molecules necessary for life. On early Earth 4 billion years ago, similar organic compounds may have rained down from the atmosphere or been delivered by comets and asteroids. These compounds, mixing with liquid water and energy sources like volcanic heat or lightning, may have gradually assembled themselves into the first self-replicating molecules. The first ancestors of life. Tholins may represent a frozen snapshot of a process that on Earth eventually led to you and me. On Pluto, that process was frozen in place, stopped cold. Literally. The temperatures are too low, the energy too scarce, the liquid water too deeply buried for tholins to take the next step toward biology. They are stuck in a permanent state of almost complex enough, almost warm enough, almost alive. But here is the speculative thought that haunts the edges of planetary science. Pluto has tholins on its surface. Pluto also has, as we are about to discover, liquid water hidden deep beneath that surface. What if, somewhere in the dark boundary between the frozen crust and the underground ocean, tholins have been slowly leaking downward for billions of years? What if they have been dissolving into that hidden water, mixing with minerals, reacting with faint traces of heat? What if, in the deepest, darkest place in the outer solar system, the ingredients for life have been quietly stirring together in a pot that nobody has ever looked inside? It is almost certainly not the case. The conditions on Pluto are so extreme, so hostile, so unimaginably cold that life as we understand it would have virtually no chance of forming. But science is not built on certainty. It is built on questions. And the question of what happens when tholins meet liquid water in total darkness is one that nobody can answer yet. Not until we go back. Not until we look deeper. Not until we crack open the frozen crust and peer into the abyss below. Because beneath the red snow and the floating mountains and the churning heart of poison, something is hiding. Something liquid. Something that physics says should not be there. An ocean in the dark. There is something buried beneath Pluto's frozen surface that scientists did not expect to find. Something that breaks the rules of what a cold, distant, exiled world should contain. Something that, on Earth, we associate with rivers and rain and oceans and life. There is liquid water beneath Pluto, not on the surface, not visible in any photograph, not detectable by any instrument aboard New Horizons directly, but buried beneath miles of frozen rock and ice, hidden in the permanent dark of Pluto's interior. The evidence strongly suggests that a vast ocean of liquid water has been quietly sitting there for billions of years, waiting, in the cold, in the silence, completely alone. The first hint came from the heart itself, from Sputnik Planitia. Scientists knew that this massive nitrogen glacier, 1,000 miles wide and several miles deep, represented an enormous concentration of mass sitting in one spot on Pluto's surface. In planetary science, when you have a large concentration of mass on a rotating world, that mass creates a gravitational imbalance. It pulls the world slightly off its rotational axis. Over time, the world should tip and reorient itself, rotating until the heavy region settles into a specific position relative to its largest gravitational partner. This process is called true polar wander, and on Pluto, the evidence shows that it happened. Sputnik Planitia sits almost exactly on the opposite side of Pluto from Charon, in precisely the position where the physics of tidal forces and rotational dynamics would place a large mass concentration over millions of years. The heart moved Pluto. The weight of the glacier was so enormous that it dragged the entire planet around until it found a new balance point. But here is the problem. When scientists ran the numbers on this reorientation, they found that the nitrogen glacier alone was not heavy enough to explain the full extent of Pluto's tipping. The nitrogen ice is dense, but it is sitting in a depression, a basin carved out by a massive ancient impact. The mass of the glacier filling that basin should not, on its own, create a positive gravitational anomaly. If the basin is simply a hole filled with ice, the mass of the ice roughly compensates for the mass of the rock that was blasted away when the crater formed. The net gravitational effect should be close to zero. It should not be enough to tip the planet. For the polar wander to work the way the data shows it did, there needs to be additional mass underneath Sputnik Planitia, something heavy, something dense, something sitting deep beneath the surface, adding gravitational weight to the region and creating the imbalance that tipped the world. The most logical candidate, the one that fits the physics most cleanly, is a subsurface ocean of liquid water. Liquid water is denser than ice. This is one of water's most unusual properties, and one that makes life on Earth possible. Most substances are denser in their solid form than in their liquid form. Water is different. When water freezes, it expands slightly and becomes less dense, which is why ice floats. But this also means that liquid water, sitting beneath a layer of ice, is heavier than the ice above it. If there is a large body of liquid water beneath the impact basin of Sputnik Planitia, it would create a significant positive mass anomaly. Enough extra gravitational pull to explain the polar wander. The numbers work, the physics fits, the ocean explains the heart. But liquid water at Pluto's distance from the Sun seems impossible. Everything out there should be frozen solid. The surface temperature is nearly minus 390 degrees Fahrenheit. At that temperature, water should have frozen billions of years ago. So how is liquid water surviving in Pluto's interior? Two mechanisms work together to keep it from freezing. The first is pressure. Deep beneath a thick layer of ice and rock, the weight of everything above presses down on the water with enormous force. This pressure lowers the freezing point of water slightly, allowing it to remain liquid at temperatures that would normally freeze it solid. The deeper the ocean, the more pressure, and the better the insulation from the cold surface above. The second mechanism is heat. Pluto's rocky core contains radioactive elements, uranium, thorium, and potassium, that decay slowly over billions of years and release a small but persistent amount of thermal energy. This radiogenic heat seeps upward from the core into the surrounding ice, creating a warm enough environment at the rock-water boundary to maintain a liquid layer. Scientists estimate that this subsurface ocean could be hundreds of miles deep, sitting beneath a shell of ice perhaps 100 to 150 miles thick. If these estimates are correct, Pluto's ocean contains more liquid water than all of Earth's oceans combined, an enormous body of water in the darkest, most remote corner of the solar system. A hidden sea on a world we almost forgot to study. And then there is the question, the one that has no answer yet, the one that sits at the intersection of science and imagination and refuses to go away. Could something live in that ocean? On Earth, we have discovered life in places that once seemed equally impossible. Hydrothermal vents on the ocean floor, where superheated water gushes from cracks in the seabed at temperatures above 700 degrees Fahrenheit, are surrounded by rich ecosystems of bacteria, tube worms, crabs, and shrimp. These creatures live in total darkness, fed not by sunlight, but by the chemical energy released by the vents. We call them extremophils, organisms that thrive in extreme conditions. We have found living bacteria inside Antarctic ice, inside highly acidic hot springs, inside solid rock, miles beneath Earth's surface. Life, once it gets started, proves remarkably difficult to stop. Pluto's subsurface ocean has several things going for it as a potential habitat. It has liquid water, the universal solvent that all known life depends on. It may have contact with the rocky core below, which could provide minerals and chemical gradients similar to those around hydrothermal vents on Earth. It has existed for billions of years, a long time for chemistry to experiment. And it has the organic molecules from tholins slowly filtering downward through cracks in the ice, providing a potential source of carbon-based building blocks. What it lacks, as far as we know, is energy. Life on Earth that does not depend on sunlight depends instead on chemical energy, the energy released when certain minerals react with water. Whether Pluto's rocky core provides enough of this chemical energy to sustain even microbial life is completely unknown. The honest answer is that we do not know enough about the ocean's composition, its temperature, its chemistry, or its contact with the core to say anything definitive. There is also a more unsettling speculation that lives at the fringes of this discussion. Some researchers have noted that the organic-rich environment of Pluto, combined with a long-lived liquid water interior, makes it a candidate for what is called a cold origin of life scenario. The idea that life does not necessarily require warmth to begin, that given enough time and the right chemistry, even in near-freezing water, self-replicating molecules could form. This idea is controversial and far from mainstream, but it has not been dismissed. We simply do not know what swims in Pluto's dark ocean, if anything swims there at all. And that not knowing, that honest, humbling uncertainty at the edge of science, is itself a kind of wonder. Because every time we have pointed our instruments at a place we assumed was barren and lifeless, the universe has surprised us, and the universe still has Pluto's ocean to answer for. Above all of this hidden water, above the frozen crust and the red-stained mountains and the churning nitrogen heart, something equally unexpected was waiting for new horizons. Something gossamer and delicate and heartbreakingly beautiful. Something that should not have existed at all around a world this small and this cold and this far from the sun. Pluto had an atmosphere, and that atmosphere had a color. As New Horizons screamed past Pluto at 30,000 miles per hour and began its long journey deeper into the Kuiper Belt, it did one final thing. It turned around. The spacecraft rotated in space, pointing its camera back the way it had come, back toward Pluto, now receding behind it. And it waited for the precise moment when Pluto would pass in front of the distant sun. When that moment came, when the tiny dark disk of Pluto eclipsed the faraway point of light that is our star, New Horizons captured one of the most beautiful and unexpected photographs in the history of space exploration. The image shows Pluto as a dark silhouette against the black of space. The sun is behind it, reduced to a brilliant point of light peeking around the edge. And surrounding the dark circle of Pluto's body is a thin, a delicate ring of light, a halo, gossamer and glowing. It wraps around the entire planet like a whisper of luminescence against the void. And it is blue. Pluto has a blue sky. Not a bold, deep blue like Earth's daytime sky. Something much softer, much more fragile. A pale, ethereal blue glow, barely there, clinging to the edges of a world where almost nothing should cling to anything. It was the last thing anyone expected, and it stopped planetary scientists in their tracks. To understand why Pluto has an atmosphere at all, you need to understand how thin the boundary is between solid and gas in the outer solar system. Sputnik Planitia is filled with nitrogen ice. The surface of Pluto is covered in patches of methane ice and carbon monoxide ice. These frozen substances do not require much energy to transform from solid to gas. Even the faint warmth of the distant sun, hundreds of times weaker than what reaches Earth, is enough to cause a small fraction of this surface ice to sublimate, turning directly from solid to gas without becoming liquid first. This sublimated gas rises off the surface and forms an extremely thin atmospheric layer above the planet. Pluto's atmosphere is almost unimaginably thin. The surface pressure is roughly 100,000 times less than Earth's atmospheric pressure at sea level. If you were standing on Pluto's surface, this atmosphere would be completely unbreathable and virtually undetectable without instruments. It is less dense than the best vacuum humans can create in a laboratory on Earth. Standing inside, it would feel no different from standing in open space. And yet, it exists. It has structure. It has layers. And it does something extraordinary with the faint sunlight that passes through it. The blue color of Pluto's atmospheric halo comes from the same tholins we encountered earlier coating the mountain peaks. When ultraviolet sunlight reacts with methane in the upper atmosphere, it creates tholin particles. These particles are small, much smaller than the wavelength of visible light, and particles this small have a special relationship with light. They scatter shorter wavelengths more efficiently than longer ones. Short wavelengths of visible light are blue. Longer wavelengths are red. When tiny tholin particles scatter sunlight, they preferentially scatter the blue end of the spectrum, creating a blue haze. The same scattering mechanism gives Earth its blue sky. On Earth, it is nitrogen and oxygen molecules doing the scattering. On Pluto, it is organic haze particles made of frozen chemistry. Two entirely different worlds, two entirely different processes producing the same achingly beautiful color. But Pluto's atmosphere does not stay the same. It breathes. It changes with the seasons. And Pluto's seasons are unlike anything in the inner solar system because Pluto's year is so extraordinarily long. One Plutonian year, one complete orbit around the Sun, takes 248 Earth years. And because Pluto's orbit is tilted and elongated, the difference between its closest and farthest points from the Sun is significant. At its closest, Pluto is about 2.7 billion miles from the Sun. At its farthest, it is nearly 4.7 billion miles away. That difference in distance translates to a dramatic difference in how much solar energy reaches the surface. During Pluto's summer, when it is closer to the Sun, the surface warms very slightly. More ice sublimes. The atmosphere thickens. The atmospheric pressure, though still tiny by any earthly standard, increases measurably. As Pluto moves away from the Sun and winter approaches, the surface cools dramatically. The nitrogen and methane that had sublimated back into gas begin to refreeze onto the surface. The atmosphere literally collapses. It falls from the sky as frost. Scientists believe that during Pluto's deep winter, most of the atmosphere freezes out entirely, leaving virtually nothing above the surface. The sky above a winter Pluto might be absolutely empty. A world with no air at all, wearing its own atmosphere as a thin coat of frost on the ground. New horizons arrived during Pluto's late summer. The atmosphere was near its maximum thickness, which is why the instruments could measure it at all. Had the spacecraft arrived a few decades later, during the long Plutonian winter, there might have been almost no atmosphere left to detect. We got lucky with the timing. New Horizons also measured the temperature of Pluto's atmosphere and found something puzzling. The upper atmosphere is significantly warmer than models predicted. Scientists expected the temperature to drop steadily with altitude, as it does on Earth. Instead, Pluto's upper atmosphere is warmer than the surface, a condition called a thermal inversion. On Earth, similar thermal inversions occur in the stratosphere, where ozone absorbs ultraviolet light and creates a warm layer above the cold lower atmosphere. On Pluto, the mechanism appears to involve the Tholin haze particles absorbing solar energy and re-radiating it as heat. But the details are still being worked out. The atmosphere of Pluto remains one of the least understood and most actively debated aspects of the entire flyby. There is one more atmospheric discovery that deserves attention. New Horizons detected that Pluto is losing its atmosphere to space. The solar wind, a constant stream of charged particles flowing outward from the Sun, strips away the outermost molecules of Pluto's thin atmospheric layer. This atmospheric escape rate is much slower than scientists had predicted before the flyby. Earlier, models suggested Pluto was losing its atmosphere at a rapid rate, almost violently. The actual measurements showed a much gentler loss. This slower escape rate means that Pluto's atmosphere has likely been stable for much longer than previously thought, and that the planet has retained more of its original volatile material than anyone expected. The blue haze, the collapsing winter atmosphere, the thermal inversion, the gentle loss to the solar wind. Every measurement New Horizons made of Pluto's atmosphere added a new layer of complexity to what had been assumed to be a simple, dead world. And all of this was happening above a surface where, as the spacecraft turned away and headed deeper into the void, one final piece of the story was waiting to be understood. Because Pluto does not face this strange and beautiful existence alone. Hanging in its sky, always present, never moving, never rising, and never setting, is a companion. A massive moon born from catastrophe, stained red at its pole from Pluto's own bleeding atmosphere, locked in a gravitational dance so intimate that the two worlds effectively hold each other up, Pluto and Charon. Two exiles at the edge of everything, two worlds sharing one fate. Pluto does not orbit alone. It never has. Hanging permanently in its black sky, enormous and unmoving, is a world almost half its own size. Not a small, distant moon like the ones that orbit Earth or Mars, tiny rocks you might mistake for bright stars. This is Charon. And Charon is so large, so massive relative to Pluto, that calling it a moon feels almost dishonest. It is more like a partner, a companion, a gravitational equal sharing the same frozen kingdom at the edge of the solar system. The story of how Charon came to exist begins with violence, catastrophic, planet-shattering violence. Scientists believe that roughly 4 billion years ago, early in the history of the solar system, a large object crashed into the young Pluto at high speed. The collision was enormous. The impacting body may have been comparable in size to Pluto itself. The crash shattered both objects, sending vast amounts of material spraying outward into space in a cloud of debris and shattered ice. Over time, gravity pulled this debris back together. Some of it reaccreted onto Pluto, rebuilding the planet's body. But a significant portion of the ejected material collected at a certain distance from Pluto and gradually formed a new world, Charon, born from the wreckage of a collision that should have destroyed everything. This origin story is strikingly similar to the leading theory for how our own moon formed. Scientists believe that a Mars-sized object struck the early Earth about 4.5 billion years ago, ejecting a vast cloud of molten rock that eventually coalesced into the moon. Two worlds in the solar system, Earth and Pluto, each carrying a companion born from ancient catastrophe, each scarred by the same kind of violent beginning. Charon's diameter is about 750 miles. Pluto's diameter is about 1,400 miles. Charon is therefore roughly half the size of Pluto by diameter, which makes it by far the largest moon relative to its parent body anywhere in the solar system. Our moon is about 1/4 the diameter of Earth, which is already considered unusually large. Charon is half. The ratio is unprecedented among known planetary systems. and this extreme size ratio has consequences that make the Pluto-Charon system unlike anything else we know of. On Earth, the Moon orbits our planet. The Moon's gravitational pull causes tides in our oceans and has gradually slowed Earth's rotation over billions of years. But Earth is so much more massive than the Moon that the center of their shared orbit, called the barycenter, sits deep inside Earth's body. The Moon orbits Earth, not a point in space. On Pluto, the situation is completely different. Charon is so massive relative to Pluto that their shared barycenter, the point they both orbit, sits outside Pluto's body. It sits in empty space between them. Both Pluto and Charon orbit this invisible point in the void. Neither one orbits the other. They orbit together. A true binary system, spinning around a shared center of gravity that hangs in open space like an invisible anchor. This binary relationship has created another remarkable phenomenon. See, both Pluto and Charon are tidally locked to each other. On Earth, our Moon is tidally locked to us, meaning the same side of the Moon always faces Earth. We never see the Moon's far side from Earth's surface. But Earth itself is not tidally locked to the Moon. Earth spins freely. On Pluto, the tidal locking is mutual. Pluto always shows the same face to Charon, and Charon always shows the same face to Pluto. They are frozen in a permanent stare, each world keeping one face permanently turned toward the other, one face permanently turned away, forever. The consequences of this are strange and beautiful. If you stood on the side of Pluto that faces Charon, you would see Charon hanging in the sky above you. Enormous. Far larger than our Moon appears from Earth. It would span an angle in the sky about 8 times wider than our full Moon. And it would never move. It would never rise. It would never set. It would simply hang there, massive and pale and silent, watching you. Day after day. Year after year. For as long as you stood on that spot, Charon would be there, motionless in the black sky. But if you walked to the other side of Pluto, crossed over to the hemisphere that faces permanently away from Charon, you would never see it at all. Not once. Not a glimpse. Charon would be forever hidden behind the planet beneath your feet. One side of Pluto lives in Charon's constant company. The other side has never seen it and never will. Now look at Charon itself. When New Horizons photographed it in detail for the first time, scientists saw a world with its own dramatic geology. Enormous canyons stretch across its surface, one of them running for nearly 1,000 miles, making the Grand Canyon look like a scratch. The surface is heavily cratered in some regions and surprisingly smooth in others, suggesting geological activity in its past. But the feature that captured everyone's attention was at the North Pole, a massive, dark reddish-brown stain covering the entire polar region like a bruise on pale skin. Scientists named it the Mordor Macula, after the dark and terrible land in Tolkien's Lord of the Rings. The name fits. It is dark, it is vast, it is unsettling, and its origin is extraordinary. The Mordor Macula is not volcanic. It is not a crater. It is made of tholins, the same organic compounds that coat Pluto's mountain peaks. But these tholins did not form on Charon's surface. They came from Pluto. During Pluto's warmer seasons, methane gas escapes from Pluto's thin atmosphere and drifts through space toward Charon. Charon's North Pole, during its long winter, drops to such extreme temperatures that this methane gas freezes onto the polar surface when it arrives. Over Pluto's summer, when ultraviolet light hits this frozen methane, it converts to tholins. Season after season, century after century, Pluto has been breathing its own atmosphere onto its companion, painting Charon's pole red with its own organic chemistry. They share an atmosphere. These two worlds, locked in their permanent gravitational dance, are so close and so intimately connected that they breathe together. Pluto exhales, and Charon catches what drifts across the void between them. Two exiles sharing one bleeding sky, and circling wildly around this central pair are four small moons, Nix, Hydra, Kerberos, and Styx. All four are believed to be debris from the same ancient collision that created Charon, smaller pieces of the shattered material that did not accrete into the main moon. They are tiny. Nix and Hydra, the largest of the four, are only about 25 to 30 miles across. Kerberos and Styx are smaller still. And all four of them spin in ways that are completely chaotic. On Earth, our moon rotates at a steady, predictable rate, tidally locked in its gentle orbit. The four small moons of Pluto tumble. They wobble. They rotate at irregular speeds that change over time, driven by the complex overlapping gravitational pulls of both Pluto and the massive Charon. Scientists expected them to be tidally locked like most moons. Instead, they found chaotic rotators, spinning unpredictably like tops that have been struck off balance. Hydra, for example, rotates 89 times in a single orbit around Pluto. It is tumbling in the dark. All four of them are tumbling, like the scattered bones of a forgotten giant, dancing erratically around the binary world at the edge of everything. Together, Pluto, Charon, Nix, Hydra, Kerberos, and Styx form a miniature solar system within a solar system. A kingdom of ice and darkness ruled by two worlds that hold each other in a gravitational embrace so tight that nothing, not time, not distance, not the slow dying of the outer dark, has ever broken it. We have traveled far, 4 billion miles from the warmth of everything familiar. We have crossed the freezing dark, descended into the churning heart of a toxic glacier, climbed mountains of frozen water harder than steel, stood beneath a sky that rains red organic dust, and peered into the possibility of a hidden ocean that should not exist. We have watched two worlds hold each other in an unbreakable gravitational embrace at the edge of the solar system. And now, standing at the end of this journey, it is time to ask the question that all of this has been quietly building toward. What is Pluto truly, and why does it matter that we understand it? Pluto is the largest known object in the Kuiper Belt. That title, the one that replaced planet in the vocabulary of astronomy, is not a consolation prize. The Kuiper Belt is not a dumping ground. It is a vast ring-shaped region of the solar system stretching from the orbit of Neptune at roughly 30 astronomical units from the Sun to about 50 astronomical units out. 1 astronomical unit is the distance from Earth to the Sun, about 93 million miles. The Kuiper Belt, therefore, spans a region from about 2.8 billion miles to roughly 4.6 billion miles from the Sun. It is enormous, and it is filled with thousands of icy objects, the frozen leftovers from the formation of the solar system 4.5 billion years ago. In this frozen kingdom, Pluto is the undisputed ruler, the largest, the most complex, the most geologically active, the most surprising object in the entire belt. And this is precisely what makes Pluto scientifically priceless. It is not a simple frozen rock. It is a preserved relic, a time capsule, a world that formed at the beginning of the solar system and has been slowly, quietly evolving ever since, far from the gravitational disruptions of the giant planets, far from the warmth that drives rapid change in the inner solar system. Studying Pluto is like finding a sealed jar from 4 billion years ago and carefully opening it to read the chemical diary of the early solar system. Every layer of ice, every mountain range, every tholin deposit, every convection cell in Sputnik Planitia is a page in that diary. The New Horizons flyby in 2015 gave us our first and so far only close look at this diary, and what it revealed fundamentally changed how planetary scientists think about small worlds. Before 2015, the dominant assumption was that small, cold, distant worlds are geologically dead. They form, they cool, they freeze, they stop. The internal heat that drives geological activity, volcanism, tectonics, atmospheric cycling drains away quickly in small bodies because small bodies have less mass and therefore less radioactive material generating heat. A world as small as Pluto, at a distance as extreme as Pluto's, should have gone geologically silent billions of years ago. It should be a cratered, frozen, featureless ball, dead as a doorstop. Instead, it has floating mountains, a convecting glacier, a weather cycle, a blue atmosphere, a subsurface ocean. It is geologically alive in ways that no model predicted, and this has enormous implications for how we think about the hundreds of other similarly sized worlds scattered throughout the outer solar system and beyond. If Pluto can be this complex and this active, then perhaps Eris is too. Perhaps Makemake and Haumea, two other large Kuiper Belt objects, harbor their own hidden surprises. Perhaps the outer solar system, which we have long dismissed as a frozen graveyard, is actually a vast collection of quietly living worlds, each one a unique experiment in planetary evolution, each one a world in its own right. The question of future missions to Pluto is one that burns in the minds of many planetary scientists. New Horizons gave us a brief, brilliant glimpse, but a flyby is not enough. A flyby is like driving past a city at highway speed and trying to understand its culture from what you glimpse through the window. What planetary scientists dream of is an orbiter, a spacecraft that enters Pluto's orbit and stays. That circles the planet for years, mapping every inch of its surface in high resolution, studying the seasons as they change, watching the atmosphere collapse in winter and rebuild in summer, probing the subsurface with radar to confirm the ocean and measure its depth, and perhaps one day delivering a lander to the surface. A machine that sits on the nitrogen glacier of Sputnik Planitia and tastes the ice, that drills through the surface and listens for the sounds of convection below. Such a mission is technically challenging, but not impossible. The main obstacle is time. Getting an orbiter to Pluto and slowing it down enough to enter orbit requires either a very large amount of fuel or a very long travel time. New Horizons had no fuel to slow down. It flew past because stopping was not an option. A future orbiter would need to carry far more propellant, making it heavier, requiring a bigger rocket, increasing the cost enormously. Scientists have proposed various mission concepts over the years, some using aero capture techniques, where the spacecraft uses Pluto's thin atmosphere to slow down. Others proposing nuclear electric propulsion systems that could provide sustained thrust over the long journey. None of these missions have been approved or funded yet, but the scientific community has not stopped dreaming. There is something deeply human about the way Pluto has captured our imagination. It is not the biggest world. It is not the closest. It is not the easiest to reach. It offers no resources, no landing sites for future colonists, no strategic value in any conventional sense. And yet, people love it in a way that they do not love Neptune, or Uranus, or even Mars. The fury that erupted when the IAU stripped it of its planetary status was not a scientific debate. It was an emotional response. Millions of people felt something when Pluto was demoted. They felt that a wrong had been done, that something small and quiet and distant and beloved had been unfairly kicked out of a club it deserved to belong to. Maybe that is because Pluto is easy to identify with. It is the underdog, the small one at the edge, the one that does not fit neatly into the established categories, the one that breaks the rules not out of arrogance, but simply by being what it is. We have all felt, at some point, like the smallest circle at the end of the line, like the one that does not quite belong. And Pluto, in its silent, frozen 4 billion mile exile, keeps orbiting anyway. It does not need our classification. It does not need our validation. It existed long before we named it. It will exist long after we are gone, long after our sun swells into a red giant and swallows the inner planets, long after Earth's oceans evaporate and its atmosphere is stripped away, long after the last human thought is thought and the last human breath is breathed. Pluto will still be there, still orbiting, still churning its nitrogen heart, still floating its ice mountains across a toxic glacier, still wearing its crown of red snow, still holding Charon in its gravitational arms, still keeping its ocean in the dark, a king without a title, a world without an audience, a beauty that asks nothing of the universe except to be left alone, to dance in the cold and the quiet for as long as the sun still burns. And now, let the silence of that dark come gently toward you. Let the image of that pale heart glowing at the edge of the solar system settle into your mind like frost settling on a frozen plain. There is nothing to solve tonight, nothing to figure out. The universe is unimaginably vast and ancient and full of hidden oceans and floating mountains and red organic snow falling in slow, eternal silence. And you are here, warm, breathing, resting, connected to all of it by the simple fact that the atoms in your body were forged in the same cosmic fire that built Pluto, that built Charon, that scattered the Kuiper belt across the outer dark. You are not separate from this story. You are inside it. You always have been. Let your breath slow now. Let your thoughts drift like ice mountains on a nitrogen sea. Somewhere out there, 4 billion miles away, a frozen heart is still beating. And here, wherever you are, so is yours. Rest now. The universe will still be here when you wake.